The last part of Unit 4 will be a look at the motor tracts. Now, it is very, very important to understand that as we look at motor tracts, the direction of flow of these tracts is completely opposite of everything that we've looked at up to this point. In other words, the general sensory tracts and the special sensory tracts have been ascending tracts. They've been heading towards the cerebrum. The motor tracts are going to be descending tracts. They are going to be coming from the cerebrum and coming down to lower parts of the central nervous system. So the first tract that I want to look at is the cortical spinal tract. And the cortical spinal tract is going to be the major voluntary motor tract to the body. And so as we look, we're going to say that this tract is going to begin up here primarily in area 4 of the cerebrum. And we want to remember that area 4 is also somatotopically oriented. So we're going to see the head, the arm, the trunk, and then the leg across the cerebrum. But also, and I'm going to put this in parentheses, we're going to see fibers that come from area 6 and also some fibers that are going to come from area 312. And the area 6 fibers are going to be those fibers which are going to be associated with the planning of motor activities. And then area 312 is actually going to be for proprioceptive information. But then these fibers are going to come down. And they're going to pass through posterior limb of the internal capsule. From there, they will pass through, first of all, the midbrain, Specifically, we're going to come down through the cerebral peduncles. We're going to come down through the pons, specifically the basilar pons. And finally, we're going to come down through the medulla. And we're going to go through the pyramids. So this is going to come down like this. Then at the very, very distal end of the pyramids, we're going to see that anywhere from 85 to 90% of the fibers are going to cross the midline. And they are going to cross the midline in the decussation of the pyramids. And then these fibers are going to descend down through the spinal cord in the lateral cortical spinal tract. And then at their proper spinal level, these fibers will then synapse, and these fibers will come out to various muscles of the body. But about 15 or so % of the fibers are going to stay on the same side. These fibers are going to descend as the ventral cortical spinal tract. And these fibers are going to stay on the same side, where at their proper spinal level, they are going to synapse, but now we're going to have a bilateral distribution of the nerve fibers. So notice that the lateral cortical spinal tract is going to stay on the opposite side, but only project to one side, whereby the ventral cortical spinal tract is going to come out and then go to both sides. Well, what we can do then is we can describe the cortical spinal tract as a 2-neuron system. The first neuron in this system is referred to as an upper motor neuron. Upper motor neurons are found only in the central nervous system. The second neuron in this system is called a lower motor neuron. Lower motor neurons are going to begin in the central nervous system, but they are going to distribute through the peripheral nervous system. This is important later on when you get to clinical neurology, because the signs and symptoms of a paralysis due to an upper motor neuron lesion is much different than a lower motor neuron lesion. Next, I want to look at the cortical bulbar tract. And you'll remember from when we talked about the pons that the cortical bulbar tract was associated with cranial nerve innervation that have voluntary motor activities. And what I'm going to do is I'm going to divide this into two templates. The first template I'm going to do is related to eye muscle innervation. And then the second template are the other cranial nerve innervations. So if we look at eye muscle innervation, we are going to see that this is going to begin in area 8 of the cerebrum. And we are going to have neurons that are going to come down, and they are going to go to two different nuclei. So I'm going to show two neurons here. The one on top is the rostral interstitial nucleus of the medial longitudinal fasciculus. The lower one is going to be the paramedian pons nucleus of the pontine reticular formation. So again, we're going to see neurons that are going to come down, and they're going to go to one or the other of these nuclei. Then from there, we're going to have innervation to the ocular motor nucleus, trochlear nucleus, or abducens nucleus. And so out of the rostral interstitial nucleus, I am going to see a bilateral innervation to the ocular motor nucleus. Out of the interstitial nucleus, I'm going to see a bilateral innervation to the trochlear nucleus. And then finally, out of the paramedian nucleus, I'm going to see a bilateral innervation to the abducens nucleus. So for testing purposes, you will be drawing only one of these pathways, and the question will be worded in such a way that you will know that you should be using the ocular motor nucleus, trochlear nucleus, or abducens nucleus. If you need to review the muscles that are innervated by these different cranial nerves, please do that. Then I want to look at what I call the other cranial nerve nuclei. And so we're going to show that this pathway is going to begin from area 4. And we're going to see that the neurons are going to come down, and they are going to pass through the genu of the internal capsule. The first nucleus that we have voluntary motor control over, that's not an eye nucleus, is going to be cranial nerve 5. So I'm going to show a circle here representing the motor nucleus of cranial nerve 5. when we look at innervation associated with cranial nerves, and we talked a little bit about this again way back in Unit 2, we can have a direct innervation where the nerve comes down and goes directly to the nucleus. But we can also have an innervation where we have a synapse and then the second neuron goes to the nucleus. The one on top is called a direct innervation, and this is going to be for a very fast type of system. The one below is called an indirect, but this is going to be a slower system because of that synapse. But because of that synapse, we get more control over the system, whereby the direct, we have less control. So as we look at these different pathways, we want to ask the question, do we have a fast system with less control, or do we have a slow system but more control? Well, what we do when we look at motor nucleus of cranial nerve 5 is we're going to get around that system by using both direct and indirect innervations. And that is going to be a bilateral type of innervation. Then, if I move down, my next nucleus that I have control over is the facial nucleus. What we can do is we can take the facial nucleus and divide it in half. The part above is for the upper face. The part below is for the lower face. So when we look, we're going to see that we're going to have fibers that begin in area 4, come down through the genu, and then we're going to see that these neurons are going to cross the midline and have an indirect innervation to both the upper and lower face. But when we look, we're also going to have fibers coming down from the same side. And these fibers are going to give a direct innervation to just the upper face. By doing this, what we have accomplished is that we have both direct and indirect innervation to the upper face. And the reason that that's important is because of the eye. As I come down, my next is going to be nucleus ambiguus. Nucleus ambiguus is going to receive innervation area 4, genu, cross the midline, and then we're going to have an indirect innervation to the opposite side. And finally, the last of the nuclei that I have voluntary control over is going to be the hypoglossal. And we're going to see all of this coming down, and then we're going to have both direct and indirect innervation to the opposite side. So as you are working with this, make sure that you know the different sequences and the different pathways. But also, again, if you need to review muscles that are innervated by these nerves, make sure that you do that.